Welcome to the class. So today we are going to discuss about some basic concepts regarding the Fermat principle. That is, before going to solve the Fermat principle, we must know some basic concepts. So let us study one by one. So first one, we will go for the properties of light. Reflection, refraction, dispersion, and velocity are the important properties of light. So let's go for reflection of light. When the light travels in a medium, encounters a boundary leading to the second medium, part of the incident light is returned to the first medium from which it came. This phenomenon is called reflection. Reflection of light from a smooth surface is called regular. So reflection of a light from the smooth surface. Here we can consider a mirror as a smooth surface. So the reflection from a mirror, we can call it as regular or specular reflection. When we are saying that when the light is traveling from a medium, there is one medium to the second medium, so we can consider this one of a same refractive index, the medium with the same refractive index. So the reflection from a rough surface is known as diffuse reflection. It is largely by diffuse reflection that we see in non-luminous objects around us. The difference between diffuse and specular reflection is a matter of surface roughness. In the study of optics, the term reflection is used to mean specular reflection. Sometimes we have to use the diffuse reflection, and most of the time we have to use the specular reflection. That is when the light is going to incident on the mirror. Here we have to consider that this medium, that the light which is going to incident and the light which is after reflection, both are in the same medium. In that case, we can say it as a regular or a specular reflection. So the laws of reflection. So here in the diagram or figure we can see, and the light ray AB, passing through the air. Here air is the medium from which the light is passing. The light ray AB passing through air is incident on a plane mirror and is reflected via the path, say BC. The point B, where the light is going to intersect the surface of the mirror, is called the point of incidence. And the line drawn at B, which is perpendicular to this plane, is called surface normal. The angle subtended by the surface normal and the incident ray is the angle of incident ray. That is the angle made by the incident ray to the normal, we can call it as angle of incidence, which is regularly used as I. The angle subtended by the surface normal and the reflected ray is the angle of reflection, say R. That is the angle of reflection. With respect to the normal, we can say it as angle R. So the first law of reflection says the incident ray, the reflected ray, and the normal at the point of incident are in the same plane. This phenomena or this plane is called the plane of incidence. Here you can see the angle, here you can see the angle I equal to angle R, or you can say that the incident ray, the reflected ray, and the normal both lie on the same plane. Here the medium of incident and after the reflection both are same. Second law, the angle of reflection is equal to the angle of incident. That is angle I equal to angle R. So here when you are solving for the Fermat's principle, you must know, we have to prove first one that incident ray, reflected ray, and the normal at the point of incident are in the same plane. Then we have to prove the angle of reflection is equal to the angle of incidence when we are considering a reflection of light. Now here you can note that the reflection are obeyed in the specular reflection. That is the plane. That is the mirror we can consider as the medium. And it do not hold good in the case of irregular or diffuse reflection. Refraction of light. When the ray of light traveling through a transparent medium encounters a boundary leading into another transparent medium, part of the ray is reflected and the part of it enters into the second medium. When the light is traveling through a transparent medium leading into the another transparent medium, here when we are saying that the light is traveling through a transparent medium with a refractive index, one refractive index, leading into another transparent medium of another refractive index. Here we have two different refractive indices or index. Then only the part of the ray is reflected and the part of the ray is going to enter into the second medium. If the refractive index of the first medium and the refractive index of the second medium is same, then the light travels in a straight line because the refractive index is same. When the refractive index of the second medium differs from the first one, then here you can see instead of going straight, the light bends a little bit towards the perpendicular line, that is the normal. The ray that enters the second medium is bent at the boundary and is said to be refracted. Reflection means light which is coming from the first medium. After getting reflection, the light is passing through the same medium. When you are saying a refraction, here the light enters from one medium and passes through the second medium. Here we have to consider two different types of refractive index. Thus, refraction means that the light ray follows the second medium, a direction different from its direction in the first medium. The angle r subtended by the normal and the refracted ray is the angle of refraction. Here this angle is also measured from the surface normal towards the ray. So what are the laws of refraction here? The first law, the incident ray, the refracted ray and the normal at the point of incident lie in the same plane. That is, the plane is same here. The plane is same. The angle I, angle r and the normal all are measured with respect to this plane only. Second one, the sine of angle of incident to the sine of angle of refraction for any two given media is a constant. That is the ratio of sine of angle of incident to the sine of angle of refraction for any two given media. For any two given media is a constant. That is sin I by sin r equal to mu, where mu is the refractive index of the medium. So here we have to note that the laws of reflection and refraction relates or gives only the direction of the corresponding ray, but do not say anything about the intensities of a reflected and refracted rays. This depends on the angle of incident, the two indexes of refraction, and the polarization of the incident ray. Or the law of reflection and refraction are obtained as experimental results. They can also be derived from Maxwell's equations. The superiority of this treatment is that it enables us to predict the amplitude, intensity, phase, and the polarization states of the reflected and refracted rays. Now let us go for the refractive index. What is the meaning of a refractive index? The refractive index of the medium, it relates to the medium. is defined as ratio of velocity of light in vacuum to the velocity of light in a medium. So refractive index is nothing but mu is nothing but c by v, where c refers to the velocity of light in the vacuum and v refers to the velocity of light in a medium. The refractive index is sometimes referred to as an optical density. A medium with a relatively high refractive index is said to have a high optical density, while one with a lower index is said to have a low optical density. The refractive index, suppose if I say it is a mu of 2,1, if I write it is mu of 2,1, that means the refractive index mu 2,1 of a second medium relation to the first one is defined as the ratio of a speed of light v1 and v2 in the first and the second media respectively. So here 1 and 2 refers to the first and second medium where the light is going to enter or passes through. The numerical value of a refractive index is nothing but the characteristics of the two media, but it is also depends on wavelength. And the refractive index is specified definitely only when the wavelength is stated. Unless otherwise mentioned, refractive index usually given for yellow light. The absolute refractive index for air under the standard conditions is nothing but 1.0002918, which usually we are taking it as 1. For light having wavelength of the D line of a sodium with a wavelength of 5893 Armstrong, since the refractive index for air is nearly equal to the unity, it follows that for the solid or a liquid, the absolute refractive index, the refractive index relates to air, differ only slightly. You have to remember this. You have to remember that refractive index relative to air differ only slightly. So the refractive index depends not only on the substance but also on the wavelength of light. The dependence of the wavelength is called dispersion. Now let us go for optical path. So there is a very small difference between the geometrical path and optical path. So if I consider the light is passing from a point A and to the point B, and if you are geometrically, if you are taking it, then the shortest distance L between these 2 points A and B is called geometrical path. You remember this, the shortest distance L between any 2 points A and B is called geometrical path. The length of the geometrical path is independent of the medium that surround the path AB. The length of the geometrical path is independent of the medium. When a light ray travels from the point A to B, it travels with a velocity c if the medium is air. If you consider that the medium is air, then the light ray travels from the point A to B. It travels with a velocity c and with a lesser velocity v if the medium is other than air, because here the refractive index of the second medium changes. Therefore, the light ray takes more time to go from A to B located in a medium. Then we can say mu equal to c by v. AB is the nothing but a shortest distance between 2 points A and B with respect to t. This is the distance by time. Distance by time. That is nothing but a velocity. So here the velocity we are considering it as in the air. Next one, the velocity in the medium. If I take it as v, then same thing. The light travels from the point A to B by taking t time. This is also the velocity factor. Then I can say t by t, where both the t are the time taken by the light ray in the air and in the medium respectively. Then here you can rearrange the equation, that is mu equal to capital T by small t. Then by cross multiplying, I am taking it as mu t equal to t. The above relation means that a light ray takes mu times more time to cover the distance AB in the medium. You just go through this line, that the light ray takes mu time more than the more time to cover the distance AB in the medium with respect to the air. When the light is passing from air to the medium, our second refractive index, whether diffractive index differs, then the light takes time more than the first medium. Take into account the delay, we use the another distance called optical length. If the ray of the light travels a distance say L in a medium of a refractive index mu in a certain interval of time, then we can say the distance in a air during the same interval of time. Then this is the symbol which we are using to represent the optical path. So optical path divided by the length. Optical path divided by the length is nothing but velocity of a light in a vacuum and t divided by velocity of light in a medium and t equal to mu. Or you can call it by cross multiply, we can say it as the optical path is equal to mu times of L. Mu times of L. Therefore, we can say optical path length is equal to refractive index into geometrical path length. You remember this. Optical path length is equal to refractive index and a geometrical path length. While you are studying the geometrical path length, we have to consider only the distance traveled by the light from one point to another point. But when you are studying the optical path length, we have to consider even a refractive index. So the optical path length is nothing but a refractive index into geometrical path length. Thus, the optical path length is defined as the product of refractive index and the geometrical path length. Note that if a ray travels a distance say L in a medium of a refractive index say mu, then the optical path, if the ray of light travels a distance of say small l in a medium of a refractive index say mu, then the optical path length, what is the optical path length here? Optical path length is equal to refractive index into geometrical path length. Here the refractive index we are taking it as a mu and the geometrical path length we are taking it as L. Then the optical path length is nothing but refractive index into geometrical length, that is mu times of L. In the given time, light travels in the optical path length in different media. Suppose the light travels in the distance say L1 in a medium of a refractive index mu1 and the distance L2 in the medium of a refractive index say mu2 in time, then we can say mu1 L1 equal to mu2 L2. Now the next basic required is dispersion. For a general purpose, we are going to discuss about a dispersion. This refractive index is a function of wavelength. Generally, it decreases as the wavelength increases. Consequently, light passes through a material medium will be separated according to the wavelength. This is known as chromatic dispersion. When the light passing through a material medium, when it is separated according to the wavelength, this is known as the chromatic dispersion. With the light at a normal incident, blue light would merely lag behind the red light. You remember this? When the light at the normal incident, blue light would merely lag behind the red light. With the light incident obliquely, the colors become separated in space, both surfaces refracting blue more than the red. So with a prism, the separation is even more pronounced. Note that dispersion not a proportional to the refraction. Refraction and dispersion bear no simple relationship to one another. Some glasses have the high index of refraction and a little dispersion. Others have just the opposite. When a ray of light falls on a glass prism, it's split into its different colors. So here the light is going to incident obliquely, then it's split into different colors. This display of colors is known as a spectrum of source of light. The separation of a composite beam into its constituent colors is called dispersion, and the medium which produces dispersion is known as dispersive medium. Prism only acts as a medium. Remember this, prism only acts as a medium for the separation of the 7 colors. When the light falls on the glass prism, refraction takes place. Since the wavelength of different components of the light is different, each component gets deviated by a different angle due to the difference in velocity in the glass medium. Now let us go for a Fermat's principle. Fermat's principle. So Fermat's principle is a remarkable and important principle in optics, which explains why light propagates along straight lines and the law of reflection and refraction. It forms the basics of geometrical optics. It is not so much a computational device as it is a concise way of thinking about the propagation of light. It is a statement about the grand scheme of things without any concern for the contributing mechanism. Fermat's principle of least time. So here Fermat says that reflected light travels from one point to another along the shortest path. It is clear from the figure that here you can see reflected light travels from one point to another along the shortest path. This is important here. There is shortest path. Which says, with the laws of reflection, is shorter than any other imaginable path. Is shorter than any other imaginable path from the point, say, A to C. For example, the path ADC, the length of ABC equals the length of the line AC1. Now here, consider the light which is coming from one medium to the another medium. Here we are considering the air to glass and air to air. One is air to glass and air to air. It is clear here that ABC with the laws of reflection is shorter than any other imaginable path. Now let us consider another path, say AEC. This is the one path. Suppose you consider this is the one path. And if I consider another path, geometrical path as A, D and C. And if I consider another imaginable geometrical path, say ABC. Here you can see the length of this geometrical path is shorter than the length of ADC and AEC. Then I can say the path length ABC, which complies the law of reflection, is shorter than any other imaginable path from the point A to C. For example, here ADC, the length ABC equals to the length line A to C1. What is the meaning of this? What is the meaning of this? After getting reflection from the first medium, suppose if I consider this is the mirror, when the light is going to pass from a medium 1 on the mirror with the geometrical length say AB, and after reflection, if it is getting a geometrical path of say BC, then without, suppose there is no mirror at all here, then the light is going to pass in a straight line. Now from this point we can see the length BC is equal to BC1. That means it is going to travel the same distance. They are going to travel the same distance from this. If I take the second figure now, that the refraction of light does not obey the principle of a shortest path. The reflection of light obeys the principle of a shortest path. What about the refraction here now? does not obey the principle of shortest path. The path, let us consider the paths A, B, C and A, D, C, etc. That is suppose the light is coming from this end, A to B, it's going to incident on the second medium. As the refractive index of the second medium differ from the first medium, it bends towards the normal, where the velocity decreases, a little decreases. See the length, A to B, B to C. Now if I consider another path which is close to the B, that is path A to D, D to C. Now here it is very clear that the length ADC is shorter than ABC. If I draw a straight line from A to C directly, here you can see the direct line A to C, the length here is less than ADC and ABC. So there the refraction of light does not obey the principle of the shortest path. The paths ABC and ADC are longer than the path AC. Taking this fact into consideration, Fermat suggested in 1650 that principle of shortest path be replaced with the principle of least time. The principle of the least time states that when a ray of light or a light ray travels between two medium P to Q, it follows out if all the possible paths from P to Q, a path which requires the least time. The principle of least time states that when the light ray travels between any two points, it follows out the possible paths where it requires the least time. Suppose P and Q are the 2 points in the same medium. Light needs the time dt to travel the distance, say d of L in the medium. Then what is the velocity? What velocity says? Velocity says distance between, what is the V? What is the V? Distance by time. What is the V? We can call it as distance by time. Here we are taking the distance as d of L. Time is d by dt. Velocity is the ultimate rate of change of length with respect to the time. Then I can say dt equal to dl by v. Let us take this one as equation number 1. The time required to travel the total distance, say from this P to Q, is, we can write it as t equal to, it takes all the possible paths from P to Q which requires the least time. So these are all the possible paths. That is the integration of over P to Q dl by v. We know that velocity equal to c by mu. We knew that velocity equal to c by mu from the law. We know that velocity equal to c by mu. If I substitute this value, then we can say t equal to dl divided by c by mu. Mu goes up, then I can say it is 1 by c integration over P to Q mu dl. The quantity integration over P to Q mu dl is the optical path length. If you consider different paths from P to Q, then the Fermat's principle states that dt by ds equal to 0. dt by ds equal to 0. What the Fermat principle says? Fermat's principle is the principle of a shortest or at least shortest path, that is, which is replaced with the principle of least time, that is dt by ds equal to 0, where ds is the parameter that expresses the difference between any two given paths under comparison. According to the now, if I substitute these values, then I will going to get t equal to optical path divided by c. That the light travels along the path having the minimum optical path length. Thank you.